When you first look at an organic molecule, it can be large and overwhelming. When I mention drawing organic molecules, some students tend to panic with ideas of elaborate Lewis dot diagrams with 100 plus electrons needing homes. But don't worry, I'm going to show you a quick and dirty method to draw almost any organic molecule that we will cover this semester. Before we get started, we will have to take a look at the periodic table. Now don't worry, in organic chemistry, we don't pay attention to most of it. We are only interested in the elements of life. Let's remind ourselves of a few key terms. Groups are the columns of the periodic table, and you can find the number of valence electrons by looking at the group number. Group 1 has 1 valence, 2 has 2. Skip the middle part, it isn't involved in organic bonding anyways. Group 13 has 3, 14 has 4, and so on. Now, back to the bonding. First, let's start with the organic star of the periodic table, carbon. Carbon makes up the backbone of life because of its ability to easily bond with itself and create long chains or rings. Carbon almost always bonds 4 times as shown here. 4 single bonds, 2 double bonds, a double bond, 2 single bonds, and finally the rare triple bond with 1 single bond. How do we know that carbon is going to bond like that? Remember the octet rule? Let's look at carbon. It has 4 valence electrons, which means it needs 4 more to fill its valence shell. Easy, right? So while we're thinking about valence, let's look at 2 more important players in the organic chemistry world, nitrogen and oxygen. Nitrogen has 5 valence electrons, which means it tends to bond 3 times. Oxygen has 6 valence electrons, which means it likes to make 2 bonds. Now let's talk about a highly reactive group on the periodic table, the halogens, group 17, represented by an X here. They have 7 valence electrons and are just dying to find 1 more to complete their octets. Finally, here's hydrogen, a small but important little guy in the organic chemistry world. Hydrogen, like the halogen, only bonds once. It is satisfied with just 2 valence electrons. When you are drawing organic molecules, it is helpful to fill in the hydrogen atoms last. Even though the hydrogen in group 1 and the halogens in group 17 bond similarly, hydrogen is a different animal. It has just those 2 electrons when it is bonded and is often seen as having an exposed proton or a positive side. Halogens have 3 lone pairs which cause a negative region, but let's leave that all for later. Here are the basic bonding patterns for the atoms we just looked at. Carbon is seen here with its 4 common bonding patterns. Nitrogen, which bonds 3 times, can have single bonds, 1 double bond, or 1 triple bond. Oxygen likes to bond twice and is often seen double bonded to a carbon or can have 2 single bonds. And then there's the halogens and hydrogen, which always just bond once. Lastly, don't forget about the idea of periodicity. Atoms in the same group behave similarly. Because of this, you can think of phosphorus as bonding like nitrogen and sulfur as bonding like oxygen. Here's an example to get you started. Start with carbon, add its 4 bonds, and then fill in the other atoms, keeping hydrogen for last. If you run out of atoms, make double or triple bonds where appropriate. And that's really it. Those are the most important atoms in organic chemistry, and that is an easy way to remember how they bond in organic structures.